Alright, one sec. Alright. You can see that?
Yes, yeah, we can see it.
There we go.
On your board at the side so you can see it.
So, I'm Michael Cohen. I'll be talking to you today about the phylogenetic relationships of the earliest tetrapods. So, why do early tetrapods matter? Well, you see, if you like birds or mammals or amphibians or reptiles or even humans, if you're into any of those things, then you're going to have to thank this guy down here, Tiktaalik, or one of their immediate ancestors or successors. So, any land vertebrate alive today, and some of the marine ones too, are going to be tetrapods. So, let's meet some of those early tetrapods that we have to thank for this great diversity. Actually, sorry. There's this. This is a cladogram sort of showing the transition from fish to modern-day tetrapods. I liked it because it's very nice in showing the changes of the limb anatomy, but it also has some problems to it, which we'll get to in a minute. So there's two major groups of these early tetrapods. There's the temnospondyls, who can be identified by their vertebrae. You can see they're very loosely connected in this diagram, being held together mostly by cartilage. And they have a few different shapes and sizes, different body plans. Like, you can see that a lot of them have more broad, flat skulls. There's like this guy is called Ceterops, but a lot of them look a lot like combinations of frogs and salamanders. So they're kind of interesting. You also have Ariops is probably the most famous of the temnospondyls. They were these giant sort of predatory amphibians during the Permian. We also have the other major group, which is the lepispondyls. And the lepispondyls have solid vertebrae protecting their spinal cords like most tetrapods do today. But there's some dispute as to whether they're the originators of the amniotes or if they come more from the temnospondyls. That's something that's still being researched today. So these guys have a lot more diversity in body plans. You can see they've got some little guys over here called the microsaurs, which are very reptilian-like in some of their anatomy, but they're also extremely tiny, hence the name. We've got some that have lost their limbs entirely, or have only little vestigial remnants, like this guy here. These are the Iastopods. And up here we have a Diplocolus. And these guys are just really strange. They've got like a boomerang for a head. And people are still speculating as to why they have that feature, but it's probably for something like predator protection or for display. So, looking at these and looking at evolution in general, there's a common misconception that occurs when we talk about evolution, and that's this idea that evolution goes from this smooth thing where you're guiding it over millions of years and you have like the most primitive forms, quote unquote, that are at the bottom of your tree, and then they gradually are evolved and become more advanced and better, usually ending with, of course, our humans over here as the pinnacle of progress. So, there's some things wrong with that, obviously. So, in tetrapods, there's more of a specific concept with this, that basically, like, the primitive fish forms are at the bottom, and then you have the more advanced, like, amphibian and amniotes that emerge as the more advanced and superior creatures. So, this idea has been refuted by more recent research by using CT scans and analysis of new traits, which have offered new insights into the evolution of tetrapods. So over here we have a diagram which is really complicated, so I'm not going to get into the details of it, but the point of it is that it's a micro CT scan, so you're seeing that these are some of the various features of one of those Tetrapod skulls. And the skulls are really tiny. They're only, like, maybe this long. They're basically impossible for you to analyze without, like, a micro CT scan. So, by looking at these, the researchers have found that they have some more basal features, like we would expect for like those more quote-unquote fishy creatures, like the vertebral column being heavily inside the skull instead of having more of a neck. But they also have more highly derived features of their own, like the fusion of certain bones in the skull. So there's been analysis of other microsaurs and such, and the Tetrapods, and this has allowed them to do phylogenetic analysis, and that showed that there was a massive diversification of early tetrapods with many different forms competing with each other, but only eventually the amniotes and the Lysamphibia, the things that would give rise to the modern frogs and salamanders, would emerge. All terrestrial vertebrates alive today are their descendants, and a few marine ones too, like the whales. So, in the past, one argument in favor of this ladder of progress idea was something called Romer's gap. So, who is Romer, and what is this gap, you might ask? Well, Alfred Sherwood Romer was a paleontologist who worked at Harvard. He was famous for his work on comparative anatomy and tetrapod evolution. He discovered this large gap in the tetrapod fossil record in the late Devonian era and early Carboniferous, and it's named after him. There's also several different species named after him, and he lends his name to the Romerogram, which is a type of cladogram that shows the diversity of species and genera through time. So, some have argued that Romer's gap shows that mass extinction wiped out the less advanced creatures, allowing the better ones, the amniotes and amphibians, of course, to survive. But in more recent years, there have been discoveries from Nova Scotia, Scotland, and other sites dated to well within the gap, and these seem to indicate that the gap is just a lack of fossil-bearing deposits from that time. Yeah. So, just like tetrapods, ideas have been evolving over time, and new concepts are being created, and old ones are being overturned. As new fossil discoveries narrow Romer's gap, the phylogenetic relationships among early tetrapods should become even more clear. In other words, more research is needed. And here are my citations. And now I guess I'll take any questions.
Sharing your screen.
Sure.
It's very cute. Alright, let's open up the floor to questions.
Did I explain this so well that nobody has any questions?
Nonsense. Give me a second.
Ezra.
There you go, Ezra.
In the early tetrapods, are there any, besides the vertebrae, are there any large, like, noticeable differences between them?
Like between the lepospondylus and temnospondylus?
Yes.
Yeah, if you want, I can go back to that. They have the temnospondylus have these vertebrae. They generally have large, like, muscle attachments, but there's really no, like, internal part of the vertebrae. It's all cartilage. Whereas the lepospondylus have more of, like, the traditional, like, solid vertebrae surrounding the spinal cord.
Are there any other features besides the vertebrae that are different between them?
There are. I am not familiar with. There's this. The biggest thing that's noticeable, really, though, would be the size. Like, the temnospondylus average about the size of either, like, large salamanders today, going all the way up to, like, maybe pigs, if we go to, like, Eriops. The lepidopondals, on the other hand, are generally much smaller, usually being like the microsaurs are usually like this long at the longest.
Caleb.
Is Tiktaalik considered a tetrapod or a fish?
That is a good question. I think there's still some debate on it, but most phylogenies I've seen generally place Tiktaalik closer to the fish side of things, because it doesn't really have limbs yet. It's got like it's still got fins. They just have sort of the hand structure, but it would have been able to use those to probably walk on land at least a little bit.
In your inner fish video, one of the animations had something kind of walking like that, kind of side to side.
Yep,
With a fish.
exactly.
Yeah, I think it might have been a tetrapod.
Yeah, Tiktaalik is one of Shubin's like big thing, so that's probably Tiktaalik. Yeah.
He discovered it.
Yeah, he discovered it, so he's gonna be highlighting it in his documentary.
Yeah.
But you're right, it's between, and I see your hand, that I will get to, Ezra. It's between Tiktaalik and Acanthostega that we find the transition between what we might consider paraphyletically fish and true tetrapods. So Tiktaalik's like right there, but not quite.
Yeah, like one of the papers I found had a very minimum definition of tetrapods, basically anything that has 4 limbs with defined digits, and Tiktaalik had fins still, even though it has the finger structures. So it's not a tetrapod, it's a fish, according to that definition.
I think that's a pretty good definition. All right, Ezra, you had a question and you've been very patient.
If Tiktaalik's not the first true tetrapod, then what is the first true?
Now that's a good question. Let me see if I can pull it up. One second. I do have a cladogram that it didn't fit in the slideshow. I just ran out of time, but it has one of those more like laddery kind of constructions of how tetrapod evolution worked. So here, let me see if I can share the screen again. Yeah, like so yeah, like for this, it has Tiktaalik down here, and they have tetrapods being like right above Tiktaalik here. This thing, Ventostega, is the first that they're claiming as the first tetrapod. So like Acanthostega is probably the more famous version. These are the guys that have these are the guys with the 8 fingers and the weird features like that. Yeah.
That's one of the problems with like saying the first is as soon as you say something's the first, we're gonna find another fossil.
Exactly. I'm sure this cladogram's out of date. It's from like 2009-ish.
Yeah, likely. A lot of this work goes on in Greenland and northern Canada. And I know it's pretty active, so I would imagine that it is out of date. Although it also takes us a very long time to publish, so that people know things and they're just not published yet.
Oh, and the other thing I take a grain of salt about with that cladogram is that the author's tetrapod, Pederpes, on there was like at the very top.
Fair. Very fair. I mean, we all love our critters. Ezra, do you have a follow-up or a different question?
This is a little bit of a different question. What environmental pressures led the tetrapods to become tetrapods, move onto land?
Again, a very good question. There's still some debate about this, like lots of things with tetrapods. So probably the Devonian was a very crowded place. You've got like the placoderms, the giant armored fish. You've got a whole bunch of predators. You've got like Eusthenopteron, which is used as like the basal thing, but it had pretty sharp teeth and was pretty nasty in its own right. So these things would have been swarming the oceans and rivers and brackish environments where the tetrapods were living, and the tetrapods would have had to escape somehow, so having fins that would allow you to flop onto land for a little bit was a good way to do that. There's other hypotheses too, which I've heard of, like that like they had to like get from like drying up pools, but I kind of like the escaping from predators hypothesis myself.
Yeah, I was just going to talk about the drying up pools, like lungfish in Australia today. They inhabit sort of like small lakes, ponds. We could call them ponds that dry up seasonally. So they like burrow under the water. So it's not during this time we have land masses starting to accumulate, starting to come together. So we have more and more land, less and less water. So it could be that they're inhabiting these sort of more inland places and and it would be advantageous for them to be able to move in between them as they dry up seasonally. So that's another hypothesis. But yep, we get this far back in time and it's hard to test things. Other questions? All right. So let's thank Mike